Now let's look at a concept that my calculus students tend to struggle with at first because we're just gaining familiarity with differentiability, derivatives, tangent lines, all these things, right? So this is a very sort of visual representation of derivatives, and it can be really tough to think about when you try to assign numbers to it. So what we're going to try to do is we're going to try to graph a derivative. So graphing a derivative. And we're going to do this very roughly just to get the point across on the idea. I didn't want to take the time really to get graph paper out and all that. We don't need to. So let's say that we're going to graph a function here. So let's say we'll call the function f. And let's say that perhaps f looks maybe something like this. And then as you move to the right, it does this kind of thing where it sort of flattens out like this. You could say it has a horizontal asymptote if you wanted. And let's label some values here. And I'll kind of come back and label values in red to match the function as we find that those values are important to us. All right. So let's leave it like this for now. What I want to do now is I want to sketch the f prime function based on the f function. Now the key is recognize that the outputs of f prime of x, let's write this down. If you want to know the output of f prime of x, it is the tangent slope to f. It's so important. The derivative outputs information about the function. So the output of the derivative function is the tangent slope of the original function at that x value. Okay? So what I like to do is start to think about what properties do the tangent lines of this graph look like? Well, I can see, for example, that to the left of 0, my tangent line slopes are constant. I have the same tangent line slope all the way across. So let's say that this particular guy, no matter what point I pick or what 2 points I pick, I've got a rise of 1 and a run of 1. Let's say that. Then what that's telling us, when I go to graph f prime, is that whenever x is less than 0, right, when I look at x values less than 0, for example, if I were to look at this x value right here, its tangent line would be right there, which happens to be the line itself, right? That's true for every value less than 0. The tangent line is the actual graph of the line. The slope of that tangent line at this x value would be, well, rise 1, run 1. So rise over run would be 1 over 1. So the slope of the tangent line here would be 1. And that's true for every value to the left of 0, because this is just a line. So to the left of 0, my tangent line slopes are a constant. They are all 1. So if I were to mark that over here, I would say 1 on my f prime graph. And I know to the left of 0 at least, all the way to negative infinity, my tangent line slopes would be 1. Now what happens at 0? Well, we know that a function is not differentiable if it has a sharp corner. So what happens, so just slightly to the left of 0, I have positive 1 tangent line slopes. And then immediately after 0, my tangent line slopes are now negative. You can see that. And you could also see that my tangent line slope here is steeper than it is down here. It's getting flatter as I travel along this path. That means that my tangent line slope here is a bigger negative value. It's a negative slope, but it's steep. So I've got a bigger negative value. So let's say right here, my tangent line slope goes down. Let's say that this is negative 3 and this is 1. So I rise negative 3 and I run 1. So immediately after 0, my tangent line slope jumps from 1 to negative 3. So now it's way up here at negative 3. Right? And what's happening now is my tangent line slopes are if you can imagine this marker is the tangent line, my tangent line slopes are still negative, but they're getting flatter, meaning my slope is getting smaller to smaller numbers. So it starts out at -3, but as it comes down, it might reach -1 right there, a slope of -1. And then it keeps coming down, and eventually, because of this horizontal asymptotic behavior, my tangent line turns horizontal. And so it's getting closer and closer to 0. And if this were truly an asymptote, it would never quite be horizontal. It would just keep getting more horizontal. So over here, my tangent line slope starts at negative. What am I doing putting -3 up here? Look at me. Let's be true here to ourselves. 0 is right there, so -3 is down here. I apologize for that. But my tangent line slope is -3, and it's getting closer to 0 as I move to the right, so it's doing this kind of thing. And you can see now that f prime jumps from 1 to -3. And the function is not differentiable at either of those points, so I go back and I put open circles on my graph because the derivative does not output a slope here at all, right? At the sharp corner, this function does not have an output. This derivative function does not have an output. So that's kind of the idea behind graphing a derivative function given some function. And it's not very precise, right? It might be a little better if this were on graph paper and I had grids and I could sort of approximate the tangent lines better, but really it's a rough sketch anyway to understand the behavior. Practice with this, practice with these concepts, really explore the relationship between a function and its derivative. It can be tough for a while, but you'll get it down as long as you remember that f prime is always the slope of the tangent line of f.